Look up at the sky for just a moment. The clouds that drift lazily above, the sunlight that warms your skin, and the sudden chill that makes you pull your jacket tighter. These are not random moods of the heavens. They are signs of something far greater, an invisible dance that has been shaping life on Earth for billions of years. Weather feels so familiar, yet it hides secrets deeper than most of us ever imagine. And the first mystery begins with something we see every day but rarely think about: the sun. But how can a star so far away control the air we breathe and the storms we fear? The sun is not just a distant ball of fire hanging in space. It is the engine of all weather, the constant source of energy that powers the movement of air and water across our planet. Without its heat, Earth would be a frozen, silent rock, with no winds, no rain, and no life. But the sun does not heat the Earth evenly. The equator receives far more direct sunlight than the poles, creating a contrast, a tug-of-war of temperatures. And this imbalance is where the story of weather truly begins. Why would uneven sunlight turn into the winds that sweep across continents? Imagine holding your hand near a campfire. One side of your hand warms quickly, while the other remains cool. That difference pushes the air around, creating tiny movements you can almost feel. Now expand that idea to the size of a planet. The Earth's atmosphere is constantly shifting, flowing, and rising because of these differences in heat. Warm air, lighter and full of energy, begins to rise while cooler, heavier air rushes in to take its place. This simple cycle, repeated endlessly, gives birth to winds, breezes, and even storms. But if warm air rises everywhere, why doesn't the entire sky turn into one giant storm? The answer lies in the Earth's own spin. As our planet turns, it twists the movements of air into spirals, bending straight winds into graceful curves. This effect, called the Coriolis force, is what makes hurricanes swirl and trade winds blow steadily across oceans. The atmosphere does not move in straight lines but in vast, looping currents that carry air thousands of miles. From the equator to the poles, these rivers of air connect the whole planet. Yet even with this great machinery, what makes clouds form, and why does water suddenly fall from the sky? The secret is that weather is not just about air, it is also about water. Every drop of rain, every snowflake, every storm begins with evaporation. When sunlight warms the oceans, lakes, and even the damp soil, water molecules escape into the air, becoming invisible vapor. This vapor drifts upward until it reaches cooler layers of the atmosphere, where it condenses into droplets. Gather enough droplets and you have clouds. Push those clouds higher, and they grow heavy until the sky can no longer hold them. Then, in a moment of release, the water falls back down as rain. But why does the sky sometimes give gentle showers, and at other times unleash violent storms? It all depends on balance. The atmosphere is like a giant system always searching for stability but never quite finding it. When temperatures shift too quickly, or when warm, Moist air collides with cold, dry air. The system struggles to keep its balance. Energy builds up, and the sky must find a way to release it. That release can be a calming drizzle or a violent thunderstorm, depending on how much energy is trapped. Each storm is the atmosphere's way of letting go, of trying to restore calm. But if the atmosphere is always seeking balance, why do storms never truly stop? The truth is that Earth is not a quiet planet. It is a restless one. The sun continues to shine unevenly. The oceans continue to warm and cool, and the planet keeps spinning. This ensures that the atmosphere is always in motion, always searching for a peace it can never fully achieve. Every breeze you feel, every cloud you see, is a sign that the Earth's weather engine is still running. And as small as it might seem when you stand beneath the open sky, this engine is vast enough to shape the entire planet. But if weather is always moving, what happens when we follow its path beyond the horizon? If air is the breath of the earth, then water is its heartbeat. Weather cannot exist without both, for they are woven together in an endless cycle of motion. The air carries heat and pressure, but it is water that gives weather its shape. Clouds floating above, rain soaking the soil, and snow transforming the landscape. To understand the true rhythm of weather, we must follow a single drop of water as it begins its quiet journey skyward. But how does something as heavy as water ever rise into the air? It starts with sunlight once again. When the sun's rays strike the oceans and lakes, they give energy to water molecules, setting them free from the surface. Invisible to the eye, this vapor drifts upward, carried gently by rising currents of warm air. What was once part of the sea now begins a new existence as part of the sky. And though each molecule seems insignificant, together they create vast, invisible rivers of moisture flowing above us. But what happens when these invisible rivers collide with cooler winds higher in the atmosphere? The answer is transformation. As water vapor rises, it meets colder air and begins to condense. Tiny droplets forming around microscopic dust particles or salt crystals. These droplets cling together, growing into clouds. From below, they may look like soft cotton drifting lazily, but inside, each cloud is a bustling city of droplets, constantly forming, colliding, and shifting. It is here that the first whispers of rain are born. But what decides whether a cloud remains white and harmless or dark and heavy with storms? It depends on how much moisture and energy the cloud can hold. A small cloud with little vapor remains bright and delicate. But when warm, moist air rises quickly, like after a hot summer day, the cloud grows taller and denser. Its bottom darkens as sunlight struggles to pass through, and eventually, the droplets inside become too heavy for the air to support. Gravity takes over, and the sky releases its burden. This is rain, the Earth's way of returning water back to the ground. Yet sometimes, instead of falling gently as rain, the sky delivers snow or even hail. What makes the difference? The answer lies in temperature. High in the clouds, Where air is colder, droplets freeze into ice crystals. If the crystals remain small and delicate, they fall as snowflakes, each one a unique frozen pattern. But if updrafts, powerful upward winds, carry them higher into the storm, they collect more layers of ice, returning heavier and harder each time. Eventually, when they grow too heavy, they fall as hail, sometimes small as pebbles, sometimes as large as fists. These frozen messengers remind us that weather is not just about warmth and calm. It is also about the power hidden in the sky. But how does this constant cycling of water shape not only the weather but the very life on Earth? The water cycle is the Earth's great recycling system. The rain that falls today may seep into the soil, nourishing a forest, or flow into a river, quenching a city. Some drops travel underground for decades, while others race back to the ocean in days. Eventually, all return to the sea, ready to rise again in another cloud. This endless loop not only keeps rivers flowing and plants alive, but also regulates temperature across the planet. Without the dance of evaporation and rainfall, Earth would be a desert world. But what happens when this delicate cycle is disrupted? When too much heat enters the system, evaporation intensifies. Air grows heavy with moisture, clouds gather quickly, and storms become more frequent. On the other hand, when regions lose their balance, evaporation outpaces rainfall, leaving the land parched and barren. This is how deserts expand and droughts take hold. Weather, then, is not just a passing mood of the sky. It is a careful balance that sustains all life. Yet if balance is so important, what forces are at work moving entire storms across the globe? The truth is, water is only half of the story. Clouds may form and rain may fall, but it is the winds, the invisible hands of the atmosphere, that decide where storms will travel. These winds are shaped by the planet's spin and the pull of pressure differences across continents and oceans. Together, they carry the moisture of one place to another, binding the world into a single living system. The dance of air and water is not local, not isolated, it is planetary. But if winds are the great movers of weather, how exactly do they shape the patterns of the skies we know? Stand outside on a quiet day and feel a gentle breeze against your skin. It may seem small, almost unimportant, yet that breeze is part of a vast system connecting oceans, mountains, and continents. Wind is not random. It is the great carrier of the planet, moving heat, moisture, and energy across the globe. Without wind, the Earth would be divided into extremes. Blistering heat at the equator and frozen silence at the poles. Instead, the atmosphere constantly stirs itself, balancing one region with another. But what invisible forces are strong enough to push entire seas of air around the planet? The story begins again with the sun. Because the equator receives more direct sunlight than the poles, the air there becomes warmer, lighter, and rises higher. Cooler air from the north and south flows in to replace it, setting up immense convection cells across the planet. These cells act like giant conveyor belts of air, lifting heat from one place and delivering it to another. Without them, the equator would become unbearably hot, while the poles would sink into deeper cold. But if air should flow simply north and south, why do winds twist and curve across the globe instead of moving in straight lines? The answer lies in the spin of the Earth. As the planet rotates, it bends the paths of moving air in a phenomenon called the Coriolis effect. In the northern hemisphere, winds curve to the right. In the southern hemisphere, they curve to the left. What should have been a straight path instead becomes a graceful arc, creating swirling systems of high and low pressure. This is why storms spin, why trade winds blow westward, and why the weather never follows a simple north-south divide. But if winds are bent and twisted by the Earth's spin, what happens when they meet the vast stretches of ocean below? Oceans are the partner in this atmospheric dance. Winds push on the surface of the water, creating currents that can flow for thousands of miles. These ocean currents, in turn, carry heat across the globe, warming coasts, cooling continents, and even shaping where deserts form. Together, wind and water form an interconnected system so large that a storm born in the Pacific can influence weather halfway around the world. But even beyond the oceans, winds exist in powerful, hidden streams high above our heads. What role do they play in shaping weather? High in the atmosphere, far above the clouds, are narrow rivers of fast-moving air known as jet streams. These currents race across the planet at hundreds of kilometers per hour, guiding storms like shepherds herding sheep. When a jet stream dips southward, it can pull cold air down into warm regions, sparking winter storms. When it rises northward, it can lock heat over a region for weeks. These unseen rivers are the true architects of weather, shifting the balance of entire seasons. But if jet streams have such power, what causes them to change their paths? Their movements are shaped by many forces. The contrast between warm and cold air masses, the pull of mountain ranges, even the temperature of oceans far below. As climates shift, the jet streams themselves begin to wander, sometimes stalling in place. When that happens, weather becomes extreme. Heat waves linger, storms refuse to move, and droughts drag on for months. The winds that once brought balance can instead trap regions in long spells of hardship. But what happens when the winds descend closer to the ground, into the places where we live and breathe? Closer to the surface, winds take on local flavors. Mountains redirect their paths, valleys funnel their strength, and forests slow their speed. This is why a breeze feels different on a beach than in a city, or why one side of a mountain may be lush while the other is dry. Winds shape ecosystems, carrying seeds, scattering pollen, and even carving the land itself. Every gust is a sculptor, shaping not only the weather but the face of the earth. But if winds are so deeply tied to the land, how do they also carry storms across vast continents? Storms are passengers of the wind. A thunderstorm may be born in one valley, but carried hundreds of miles before releasing its final raindrops. Hurricanes gather their strength over oceans, then ride prevailing winds toward distant coasts. Tornadoes, though short-lived, are steered by larger wind systems surrounding them. In this way, winds act like invisible highways, moving weather patterns around the globe. Yet, as powerful as these moving currents are, what happens when the balance tips and winds grow too strong to control? For most of us, weather is gentle. A light drizzle, a passing breeze, or the warmth of the afternoon sun. But sometimes the atmosphere reminds us of its true power. In those moments, the sky darkens, the winds roar, and nature seems to unleash its hidden energy in spectacular displays of force. These extremes are not accidents. They are part of the same system that gives us calm days. The difference is only in the amount of energy waiting to be released. But why does the same sky that gives us soft rain also bring violent storms? It begins with instability. When warm, moist air rises rapidly into cooler layers of the atmosphere, it sets the stage for thunderstorms. The heat fuels towering clouds that stretch miles into the sky. Inside them, droplets collide, winds swirl, and pressure shifts. The cloud becomes an engine, storing energy until it can no longer contain it. Then, with a sudden release, rain pours down, winds whip the ground, and thunder echoes across the horizon. But if thunderstorms are simply bursts of rising air, what transforms some of them into devastating hurricanes? Hurricanes are born over warm oceans, where vast amounts of water evaporate into the air. This moist air rises, creating a low-pressure zone at the surface. More air rushes in to replace it, feeding the storm. As the Earth's spin twists the system, it begins to rotate, forming a massive spiral. With every cycle, the storm gathers strength, pulling energy from the sea below. Soon, it becomes a towering monster, stretching hundreds of miles across, with winds strong enough to tear apart cities. At its calm center lies the eye, a strange reminder that even in chaos, balance exists. But if hurricanes are ocean-born giants, what about the sudden, violent twisters that appear without warning over land? Tornadoes form in a different kind of storm, supercells. These massive thunderstorms contain rotating updrafts, spirals of air rising into the sky. When wind speeds and directions shift sharply with altitude, the rotation tightens, like a skater pulling in their arms. A funnel cloud drops from the storm, and if it touches the ground, it becomes a tornado. Unlike hurricanes that last days, tornadoes may live only minutes, but their concentrated power can flatten everything in their path. They are brief, terrifying reminders of how quickly weather can change. But within both storms and tornadoes lies another mystery. What is lightning, and why does the sky set itself on fire? Lightning is the atmosphere's spark of energy. Inside storm clouds, droplets and ice crystals crash against each other, building electrical charges. The top of the cloud becomes positively charged. the bottom negative. The imbalance grows until the air itself can no longer hold it. In a blinding instant, electricity leaps across the sky, seeking balance. Sometimes it connects cloud to cloud, other times cloud to ground. The flash is lightning, and the thunder that follows is air itself exploding from the heat. In less than a second, the strike can heat the air hotter than the surface of the sun. But if lightning is a release of energy, why does it strike some places more than others? The ground plays its part. Tall structures, isolated trees, even mountain ridges, all act as pathways for lightning to reach the earth. The bolt follows the path of least resistance, finding whatever offers the easiest route. This is why cities, with their spires and towers, often experience frequent strikes, while open plains may go untouched. Yet no matter where it lands, lightning always leaves behind the same truth. Weather is not only water and wind, but also raw electricity. But if extremes like lightning and storms are dangerous, why are they also vital to the Earth's balance? Every storm, no matter how violent, serves a purpose. Thunderstorms release built-up heat from the lower atmosphere, preventing the system from becoming dangerously unstable. Hurricanes move heat away from the tropics, redistributing energy across the globe. Even lightning, destructive as it seems, helps by fixing nitrogen in the soil, enriching it for plants. What appears as chaos is in fact part of a delicate design, a way for the earth to maintain balance. But if balance is always restored, then why do we still see disasters that change entire lives in a single night? The truth is that balance is not always gentle. The atmosphere has no regard for human cities, crops, or homes. It follows only the laws of physics, moving energy where it must. When those movements collide with our world, we feel the consequences. Storms flood rivers, hurricanes level coasts, and tornadoes cut scars across landscapes. These are reminders that weather is far larger than us, and our place beneath it is both fragile and humbling. But even in the face of such extremes, how have humans learned to live with and even predict the moods of the sky? For as long as humans have walked the earth, we have looked up at the sky with both wonder and fear. Ancient farmers studied the clouds to decide when to plant seeds. Sailors watched the winds to know when to set sail, and entire civilizations rose and fell depending on the rains. Weather has always been more than background. It has been a guide, a warning, and sometimes a mystery too great to solve. But how did we first learn to read the language of the skies? In the beginning, observation was our only tool. People noticed patterns, the way red sunsets often meant fair weather ahead, or how animals behaved differently before storms. Shepherds and fishermen built wisdom over generations, passing down sayings that carried fragments of truth. These early weather forecasts were simple, but they were enough to shape survival. Yet the skies held more secrets than eyes alone could see. So how did we move from folk wisdom to the science of weather prediction? The shift began with instruments. The invention of the barometer in the 1600s allowed people to measure air pressure, revealing that falling pressure often signaled storms. Thermometers and hygrometers followed, giving us the ability to track temperature and humidity. For the first time, invisible changes in the air could be made visible through numbers. These measurements laid the foundation for meteorology, the science of weather. But if tools on the ground revealed local conditions, how did we learn to understand the bigger picture of weather across the globe? The answer came with communication. In the 1800s, the telegraph allowed weather data to be shared quickly across regions. For the first time, scientists could piece together patterns stretching beyond a single town or valley. They began to map pressure systems and track storms as they moved, creating the earliest forecasts. What once seemed unpredictable now began to follow patterns, and humanity's relationship with weather changed forever. But if telegraphs revealed the map of storms, what technology would let us see weather from above? The true revolution arrived with satellites. From orbit, satellites watched the Earth continuously, capturing images of clouds, winds, and even temperatures of the oceans below. With these eyes in the sky, scientists can follow hurricanes as they grow, watch storms spin in real time, and track changes across continents. No longer are we blind to what forms beyond the horizon. Satellites opened a new age of forecasting, where storms could be predicted days in advance, saving countless lives. But if satellites let us see the surface, how do we understand the deeper movements of air within the atmosphere? That is where supercomputers come in. Today, vast machines process millions of data points from stations, balloons, ships, and satellites, running simulations of the Earth's atmosphere. These models can predict how storms will move, how much rain will fall, and even how seasons might shift weeks ahead. Though not perfect, these forecasts give us the power to prepare. Whether that means evacuating a coastline before a hurricane or simply carrying an umbrella for the afternoon rain. But even with powerful computers, why does weather still surprise us? The atmosphere is a chaotic system, sensitive to the smallest changes. A shift in wind speed, a pocket of moisture, or even the heat of a city can alter the course of a storm. This is why forecasts grow less certain the farther into the future they look. Weather remains a dance of countless variables, and though we can glimpse its patterns, it will never fully surrender its mystery. But beyond science and technology, what deeper meaning does weather hold for us as human beings? For many, weather is more than physics, it is feeling. A sunny day lifts the spirit, while gray skies invite reflection. Rain can be comforting, snow enchanting, and storms humbling. Cultures around the world weave weather into their myths, rituals, and art. It shapes not only our survival, but also our imagination. Weather connects us to the earth in ways both practical and poetic. But if weather touches our emotions so deeply, what happens when the skies themselves begin to change in ways humanity has never seen before? Imagine standing on a beach where the waves have kissed the sand for centuries, and suddenly noticing the tide creeping higher than it ever has before. Imagine a familiar summer sky, but hotter, heavier, more oppressive than your childhood memory. The weather of tomorrow is not a distant phenomenon. It is already shaping our world today. And the question is not just what will the weather be like next week, but what will the weather be like for the generations to come? That thought alone pulls us deeper into this mystery. When scientists talk about climate change, they are not describing a single storm or a particularly hot season. They are describing a shift in the long-term patterns of weather. Averages that were stable for centuries are now bending. Storms that were rare are becoming frequent. Heat waves that once seemed extraordinary now seem almost ordinary. Each change is like a subtle brushstroke on the vast canvas of Earth's atmosphere, slowly altering the picture of the world we know. And with each brushstroke comes a quiet yet undeniable hook. How different will the painting look by the time we reach the end? One of the most pressing concerns lies in rising global temperatures. A few degrees may sound insignificant, like adjusting a thermostat slightly in your home. But for the Earth, those few degrees can determine whether glaciers hold their ground or vanish into the sea, whether deserts expand or forests thrive. The air grows hungrier for moisture as it warms, which means more evaporation, more intense storms, and greater swings between drought and flood. Each new piece of evidence leaves us with a chilling question. If a few degrees change so much, what happens if the rise continues unchecked? The oceans, too, are quietly rewriting the future of weather. Warmer waters fuel stronger hurricanes, their winds and rains growing more ferocious with each passing decade. Rising seas threaten coastal cities where millions of people live, turning what once felt like secure ground into fragile shorelines. The balance of life beneath the waves shifts as currents weaken and alter, changing weather patterns thousands of miles away. It is as if the ocean itself is whispering a warning. The calm you once knew will not always return. But perhaps the most unsettling transformation is the unpredictability itself. Farmers who once planted their crops by the rhythm of seasons now face erratic rainfall and unexpected frost. Communities accustomed to gentle winters now brace for storms that feel out of place. Entire ecosystems strain to adapt, with animals and plants migrating toward cooler regions. And we, too, are left to wonder, how do we adapt when the rules of the game keep changing? Yet, even in the uncertainty, there is resilience. Scientists are developing models that grow sharper every year, predicting the dance of atmosphere and ocean with increasing clarity. Renewable energy, sustainable agriculture, and international agreements are attempts to slow the changes, to protect a stable climate for future generations. The human story has always been one of adaptation, finding ways to endure, to thrive, even when nature tests us. The question is no longer just can we adapt, but how quickly and how wisely will we choose to act? And still, in the middle of all this, the weather retains its timeless wonder. Rainbows arc after a storm, winds carry the scent of new blossoms, Snow falls softly on quiet fields. These moments remind us that weather is not only a challenge but also a gift, a living reminder of our connection to Earth's delicate systems. The future of weather may be turbulent, but it will also continue to weave awe and beauty into our lives. And that leaves us with a hopeful hook. What beauty might we preserve if we choose wisely now? As we reach the end of this journey through the story of weather, from its ancient origins to its uncertain future, one truth shines clearly. The weather is not just around us, it is within us. It shapes the food we eat, the air we breathe, the water we drink, and the memories we carry. To understand weather is to understand a part of ourselves. And now it is up to us to decide how this story continues. If you've enjoyed exploring the hidden world of weather with me, and if you'd like to drift even deeper into the mysteries of nature and science, consider joining our community here at the Sleepy Minds. Subscribe, leave a like, and share this with someone who also gazes at the clouds with wonder. Together, we can keep uncovering the secrets of the universe, one calm story at a time.